is crude oil. What is crude oil? It's a mixture of...
Hydrocarbons.
Yeah. And what is a hydrocarbon? We'll have 2 marks in a paper.
Hydrocarbon is a compound made up of hydrogen and carbon exclusively.
Yeah. A compound containing hydrogen and carbon atoms only for the second mark. If you don't say only, you might not get the second mark. So if crude oil is a mixture of hydrocarbons found in plankton and stuff like that, so under the ocean, or what is the use of that? So, well, crude oil can actually be
Burn.
crude oil can be burnt. More importantly,
First you have to actually separate the different hydrocarbon chains from the crude oil to make sure that you're using the correct one for the correct purpose.
so crude oil is a mixture of hydrocarbons, but these hydrocarbons are all different. When we say different, what's the main difference between different hydrocarbons?
The length.
Okay, so crude oil is made up of short hydrocarbons, long hydrocarbons, and medium hydrocarbons, okay? So the way to separate hydrocarbons is fractional distillation.
Amazing.
Step 1, vaporize the crude oil. Vaporize means to turn it into a steam rather than a liquid or gooey liquid.
Otherwise known as a vapor.
No, the vapor is what happens after the steam.
Yeah, steam is a vapor.
Yeah, but not the gooey bit.
Yeah, the goo bit's a little... We don't care about that.
Okay. Step 2.
Collect the vapor at different points. So the vapor will then condense, right? And then it becomes... because the different chains of hydrocarbons.
Okay, so
Different.
enter the crude oil into the column.
Column of what?
Let the steam enter into the column.
What is this column?
That's step 3.
What's the column?
The column is hot at the bottom and cold at the top. Okay?
Mm-hmm.
There's something called Google Images where you can all find a photo of it if you're interested. But it looks something like this. And it will just be like hot and then cold up here. Okay? And then there'll be like gaps where they can escape. So cool. The next...
Table weight is how hot and cold it is.
I'm on a budget. So, as the crude oil rises, the strong hydrocarbons,
Not strong, long.
they're also strong, condense and escape straight away. The rest of the crude oil will rise, and the medium ones will condense and escape in the middle, and the weak ones will condense and escape at the top. And you raised a good point. So strong, we have to know that the strong ones are long and have a high melting point. Okay? And then the short ones, so that's what we're going to go on to next. So long hydrocarbons we're mostly talking about alkanes at the moment. We'll explain that after. They have a high melting point and a boiling point, which basically means they're strong. They are very viscous. Viscous means gooey. The opposite of viscous is runny. And they are not very flammable. So all of this is a bad characteristic of a hydrocarbon. We want the short ones because they have a low melting point, they're very runny, and they're very flammable. That means they can be burnt to produce energy very easily. Okay? So if we did fractional distillation to separate the long and the short hydrocarbons, what would we like to do next?
Well, you see, we still have a lot of long hydrocarbons, which are relatively useless, as we've already mentioned. We don't want to let those go to waste, so instead we do a thing called cracking.
So cracking is used to break down long hydrocarbons into two or more shorter hydrocarbons. For example, if we have C10H12, that could be broken down into C4H10 plus
C6H2.
I meant 22 here.
So actually now it becomes C612.
C6H12.
C6H12. Now, you'll notice here that we have an alkane and an alkene.
Okay, sure. Just the next topic.
Whenever you crack something, just remember that it's an alkane and an alkene always.
Okay, and we're going to go into alkanes and alkenes later, so don't you guys worry. These guys are probably bottom of the barrel, grade 4 students.
It's something like that.
What? They're here to learn.
We love you and we value you.
Yes.
Unlike Jason.
Okay. So, let's go into alkanes. Also, one more thing. Cracking can be done in two ways. There's steam cracking and there's catalytic cracking. Again, both ways are methods to break down long hydrocarbons into two shorter hydrocarbons.
Which are more useful.
Yes, which are more useful.
Remember that can come up as a question.
Steam cracking is done by using water or steam, so very high temperature. Catalytic cracking is done by using a catalyst.
Shocker.
Alkanes. Alkanes have a general formula, so something you can remember them as. The general formula is your friend. CnH 2n plus 2. This means there's n number of carbons. So let's say the number of carbons is 8. Then there's 2n plus 2 number of hydrogens.
So what would you do?
You would multiply the 8 by 2 to get 16 and add 2 to get 18.
Amazing.
The reason for that is very, very simple for the visual learners. So if I had 1,
Don't worry,
2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. For every carbon, there'd be 2 hydrogens. 1, 2, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2.
Now, you would have learnt this earlier in the chemistry curriculum, but carbon can have a maximum of 4 bonds at a time. This is very important for this.
So at the end, we're going to have 2 more H's. That becomes more complicated for the chemistry-only students who do alkenes in a lot more detail. For combined science students, you just have to know this. Okay. 2 more keywords. A functional group. You only need to know one thing about the word functional group. Well, you need to know all of the examples. And you need to know what a functional group is useful for. So what does a functional group tell you? A functional group determines how it reacts, how your organic compound reacts. So if it has an OH functional group, it's an alcohol. And alcohols react differently to alkenes, which are C double bond C. The last word is very complicated. Homologous series.
Not the
Homologous series.
Look out, kids. Homologous series. It's a tough one.
So, what is a homologous series? So everything in the same homologous series
Has the same general formula.
So every member has the same functional group and general formula.
Exactly.
And each consecutive member differs by
1 carbon. I'm not entirely sure that actually.
CH2. So you are actually right. Each one differs by CH2. So if I had C8H18, the next one would be
C9H20.
Yeah. Okay. So for the combined science students, we have to know a little bit about alkenes, and then you can log off for the day and go and enjoy your holidays.
Unless you're still in school, in which case, sucks to be you.
So, alkenes, they have a different general formula. It's CnH2n, and they have a different functional group, which is C double bond C. It adds up when you think about it together. So, if I had 4 carbons, then I would have to have how many hydrogens?
8.
Now, if I was drawing it, I would do C, 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 but one of them has to be a double bond. So you don't need to I would just put it on the first one to keep it simple, okay? But it can be on the other one. Now, we said that each carbon can only have
4 bonds at a time.
So this one on the right has 1, 2, 3, 4. The one in the middle already has
2.
So I can add 2 more. The next one has
3.
So I can add only 1 more. It can be at the top or the bottom actually.
It doesn't matter.
And the last one has how many?
2.
So I can add 2 more. Sometimes they put it diagonally, it doesn't matter.
So all the hydrogens are there.
So they look really random and weird, but the thing is, you just have to look out for the double bond and make sure you don't put too many hydrogens. The spec is your friend. I'm going to use the spec because I want to make sure I've covered everything. You should also use the spec. And my notes on tutingtutors.co.uk.
Good news for all the people here who don't have friends. The spec is always there for you.
This isn't a comedy channel.
Gonna have a little bit of fun while you're learning about alkanes and alkenes. Just take a moment as we go through the spec to just look over all your notes. Hopefully you'll be making them, you know.
Don't worry, I'll be editing this out.
See if you can make sure that you know everything. Please answer these questions. Just pause the video and answer these questions at your own pace. Or you could just go watch free science lessons online.
Don't say that.
We love free science lessons.
No, we don't.
He's our favourite robot.
Yeah, we do. He's an inspiration to us all.
Anyway,
We just need to know a couple of more facts about alkenes. Alkenes are more reactive than alkanes. That's because of their functional group, which is C double bond C. That is very excited to open up and turn into like that. And then it can attract more bonds like BR and BR. So alkenes can be identified. They react with bromine water, but alkanes don't. What is the color change when alkenes react with bromine water? Yep, 2.
colourless.
So what you would do is you'd set up some bromine water in a test tube. You'd put some of your alkene or alkane in there. You'd shake it. You'd wear safety goggles. And you'd look for a change of colour from orange to colourless.
Now, knowing this fact about alkenes is highly important, as you'll most likely get a question asking you what's the difference between a saturated and unsaturated hydrocarbon. Now, alkenes are always unsaturated.
Yes. Good point.
And this entire process which we're just going over is proving that it is unsaturated. So if it's more reactive, just like an alkene is, it's an unsaturated hydrocarbon. We'll get onto what a saturated hydrocarbon is later.
We've already done saturated hydrocarbons. They were the alkanes.
Yeah, but we didn't say they were saturated though.
You're
Yeah,
right.
alkanes aren't reactive. Don't say alkanes are reactive.
So when you have saturated and unsaturated fats or carbohydrates, wait, can you have unsaturated? Yeah, you can. Unsaturated and saturated carbohydrates. Which ones are healthier?
The unsaturated ones
Because they react faster.
with your body, which means you won't put on weight, just like your aging mother.
That was quite rude.
I'm talking to you, not to the viewers. Your mother's so lovely. Do better, Jason.
If anybody knows any AI which edits videos for free, please let me know.
Photoshop is always an option.
Huh?
Photoshop.
I will pay you £4 to edit my video. I will pay you to edit this video. How much?
I don't know how. I don't have the software.
You can use my iPad.
But I'll make a TikTok video out of it. I can use CapCut.
Okay. So, combined science students, bye. Okay, chemistry students.
That was so cringy. Now let's go into the real nitty
Shush,
gritty.
we have to focus.
Here we go.
I even wrote that stuff and I didn't even see it. I'm so annoyed.
Alcohols and carboxylic acids.
Okay, alcohols.
Yeah, that's right. We're not done. Alkenes and alkenes aren't the rest of it.
What is the functional group of an alcohol? OH. Okay? So if I have I could actually make a general formula. It would be CnH2n plus 2O. So if I have C4, it would just be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2. All of them would be H's, but one of them would be an OH. So there'd just be an extra O. But it has to be OH like that. That's the functional group telling you this is an alcohol. Now, alcohols are formed by reacting alkenes with water. So if I had a C, yeah, so C2H4 plus H2O, I could get C2H5OH. Okay? So CCHHHHH OH. Okay? Alcohols can also form carboxylic acids. What is the functional group of a carboxylic acid? COOH. Yes, coo. Cuckoo, cuckoo.
When you're in your exams, you need to remember the functional group of a carboxylic acid. Just think about that noise. Just think about the owl noise.
It looks like this. C double bond O OH. So it's not CO connected to OH, it's C connected to O and C connected to OH. Okay? So a carboxylic acid would be so let's say we have butanoic acid. How would we draw that? What would we start with? We first draw the carbon stem or the carbon chain. So how many carbon chains should I draw?
4.
Combined science students, come back. It's monkeys eat peanut butter. M for methane or methene or methanoic acid.
E for ethene or ethane or ethanoic acid.
And then propane and then butane. There's no such thing as methane, by the way. So we draw a carbon chain of 4. We'd put H's around most of them. And it has to be at the end, you'd have the OOOH. Do you understand?
Yep.
Okay. Now, these all combine together in the final subtopic, which is polymers. What is a polymer? A polymer is a long chain. So poly means many, so it's a long chain molecule made up of many monomers joined together.
Now, what is a monomer?
What?
No, what is a monomer?
Sorry. Sorry, we've just got told off from the librarian, so could you guys keep it quiet in the comment section, please? Don't worry, guys. When we get to topic 8, I will be buying a microphone, so you guys will be able to hear me way more clearly in my recording studio. We have two types of polymers, and addition, polymerization, and condensation polymers. So, addition polymers are when the double bond breaks okay? And what is a condensation polymer? When H2O is removed. That's condensation, when H2O is removed. So these are like two alkenes. They like forming condensation polymers.
Just an addition polymer.
And then condensation polymers are like an alcohol and a carboxylic acid or something like that. So if I had this monomer, what would be my polymer? So the double bond would break, so I'd have C. Then my H's would be at the same place, but maybe more vertical. That double bond that broke, right, it would open up and it would be able to join to itself many times. This is my monomer. This entire thing is my polymer. And this inside bit is my repeat unit. Those are the three things they test you on. Could you try to draw dibutanoic acid? Is that too confusing? Do you want any help? Any questions? Ask me questions if you're stuck.
Dibutanoic acid.
So do you remember how to draw? Okay, let's start a bit easier. Let's do dibutanol. Butanediol. Do you know how to draw butanol?
Okay, so we've got, it is a alcohol. So to draw butanol, first things first.
You don't have to explain it. You don't have to explain it. I'll explain it after. But if you have questions, ask me. How do we draw butanediol?
Well, okay. So we don't need to make it a polymer. Wait.
No. So butanediol is this thing in chemistry. So when they say di, it means two. So butanediol. Butanol would just be without the second OH. Butanediol means two of the ols, the alcohol groups.
Can I take a chip?
Of course you can, sir. No worries at all. Please like, comment, and subscribe for this.
1 like equals 1 chair for the old man.
Yes. So, what would happen is we remove not the double bond, because that's what type of polymer?
That would be a addition polymer.
Cool. So in a condensation polymer, we remove water. So H2O.
See that, guys? H2O.
So you can pick any two H's and any two O's from the ends only. You can't pick it from the middle. Okay. From the ends, okay? So what would happen is you'd basically get the C, 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 H, 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 H. Before we had OH and OH at the end, but now we just have this O. So it'd be a O. And that would just link on again and again. Do you get it?
Yeah.
So it looks nicer when it's with a carboxylic acid and an alcohol. So could you try to draw propandiol, and then could you try to draw propandioic acid?
Sure. I'll give it a go.
Do it here.
Just normal Pokemon.
So these will actually usually be given to you, and you'd have to make the polymer out of it. So put an OH there as well.
You asked for propanol.
Oh yeah, I changed it to propandiol. Put the OH and wait, make that HO. Because the H has to touch the carbon by convention of chemistry. The 1971 convention, Law 4.
Just like Comic-Con, scientists also have their own
Disclaimer, this video may contain 1 or 2 ounces of incorrect information.
information. One or 2 ounces.
Please do not sue me if you get a grade 4.
Come on, man. If you're gonna like use measurements, at least use it in like chemistry measurements, like moles.
Okay, next time.
Yeah.
That one's meant to be OH, that one's meant to be HO.
But then the hydrogen is not touching the carbon.
Yeah, I got it the wrong way around, Josh. Have you done the other one? Propandioic acid. Do it then. Perfect. So step 1, you do the carbon stem of 3. Then you put the H's and you put the double bond OOH. And then you count the carbons to make sure that some of them don't have too many.
Doesn't the CO...
You've got 4 carbons in your
Doesn't
thing.
the COOH give an extra carbon?
No, that's part of it.
Ah, cool.
Good, otherwise that's correct. So So what happens is, in a condensation polymer, what gets removed?
Water. Or
So
H2O.
what I do is, I look at my alcohol and my carboxylic acid, and I'm going to take out water like this. If they're not aligned next to each other, draw them next to each other and it becomes easier. Then, I also take out water from the other outsides. That's not it.
Man, wake up.
That's not it, is it? That's HO2. So what I wanted to do is... Okay? Then, I'm just going to draw what I've got. I've got... So I'm actually going to redraw it a bit.
Alright guys, so here's what I want you to do, right? You see, for each subscriber that we gain from this video, right? Jason will do a year back at school to make sure that something like this doesn't happen again. Only you can make it happen. So I believe in you, I trust you, I love you.
Very empowering speech.
Comment down below how empowering you found my speech.
So it's OH here. OH here. This one, we're going to do it a bit differently. We're going to do HO, OH, and those ones going down will be easier, okay? Then it will be easier. So if we align the OHs on the sides, do you see what happens? H2O can be removed. H2O can be removed way easier. It's because I drew the double bond O on the sides. But if I draw the OHs pointing to the sides, they can hold hands easily and you can remove the H2O. Yeah? Does that actually make sense? Seriously? Any questions? Now I wouldn't have any trouble combining it, so I would just get all of this stuff, C, 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 O, then I don't draw this stuff because I've crossed it out. And then I carry on, C, C, C,
O.
O. And then I draw a big line and a big line, and then an N. So I have N of these, forming N of these polymers. And then in between I just fill in the gaps. So H, 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 double bond O, H, double bond O, H. And this is actually a polyester.
Not like the one that you'd be finding in your dad's, blazer, however. This is a different kind of polyester.
Polyesters are, well, esters are used in perfumes. They smell nice. And sweets. So
How come you never use an ester then?
I use them to give you donuts for keeping your mouth shut. So clearly you're on a donut deficit of 3 now because you were late last time.
Guys, and for each like that this video gets, Jason has to buy me a donut.
Can you please don't unlike the video right now, everyone?
Make Jason stuff to buy me donuts. Raindrops falling on my
Oh, also, you know at the end we drew the polyester. We also have to write plus. You know how we wrote N of them? What do we also have to write? The byproduct, which was what? What got removed when you were making the
Remove the
polyester?
water. So
How many of them?
2
One from the inside, one from the...
outside.
So we have to write 2N, H2O. Finally, is 2 real-life examples, and then we're done. So the 2 real-life examples are amino acids and DNA. Deoxyribonucleic acid.
Deoxyribonucleic acid.
It's a large molecule essential for life. DNA encodes genetic instructions, and yes, it is okay to just read off the book sometimes. So feel free to pause the video and